Hello, and welcome to tonight's Space Sleep Story. If you appreciate what we do here, please like or subscribe for future relaxing nighttime space journeys. Tonight we embark on a contemplative journey from Mercury to Venus, a 2-month unpowered coast through the inner solar system. After completing our Mercury exploration, we depart the innermost planet, watching solar intensity gradually diminish, observing Earth reappear from solar glare, and drifting toward Venus's cloud-shrouded mysteries. So settle into your most comfortable position, close your eyes, and prepare for this peaceful transit between two dramatically different worlds. Before we begin, let us prepare your body and mind with gentle breathing. Take a slow, deep breath with me now. Inhale gently for 4 counts. Hold the peace. Exhale for 6. Feel your body releasing into stillness. As we journey between planets, your breath becomes your anchor. Inhale the vastness of space. Exhale the tensions of Earth. Each breath carries you deeper into relaxation. Another gentle breath as we continue our preparation. This time, notice how your chest rises and falls like the gentle orbital motion of our spacecraft coasting through the void. Breathe in for 4 counts. Hold for 4. Release for 6 counts, feeling gravity's hold on your thoughts dissolving. With each breath, you release a little more into relaxation. Let my voice be your guide through this peaceful interplanetary journey. Feel the stress of the day leaving your body with every exhale. Mercury exploration is complete. 30 days on the surface taught us survival at the solar system's innermost frontier. We sampled polar ice deposits, measured the planet's weak magnetic field, walked across ancient cratered terrain 4 billion years old. Now our orbital habitat prepares for departure. Today we leave Mercury orbit, beginning a 2-month journey to Venus. Innermost planet yielding to second planet. One extreme environment exchanged for another. The paradox of inner solar system navigation: leaving Mercury means traveling away from the Sun to reach Venus. Mercury orbits at 0.387 astronomical units from the Sun. Venus orbits at 0.723 astronomical units. We must climb outward through the Sun's gravitational well from 57.9 million kilometers to 108.2 million kilometers. Venus is nearly twice Mercury's distance from the Sun, yet still firmly an inner solar system resident. Earth, at 149.6 million kilometers, remains distant beyond. Tonight we coast the inner realm, that scorching region where terrestrial planets formed from primordial dust and rock. Final orbit around Mercury now. The planet rotates slowly beneath us, taking 58.646 Earth days for one rotation. Its 3-to-2 spin-orbit resonance creates a solar day lasting 176 Earth days, the second longest in the solar system. We've communicated with Earth during favorable windows, Received departure authorization from Mission Control. Systems check confirms readiness for the trans-Venus injection burn. All thermal management systems optimal. All navigation parameters calculated. All crew prepared for 2 months of unpowered ballistic coast. The departure burn will add 1.2 kilometers per second of velocity. Unlike our arrival burn, which slowed us into Mercury orbit, this departure burn accelerates us, adding velocity to escape Mercury's weak gravitational grip. But escape is relative. We remain in solar orbit, simply changing from a Mercury-matching trajectory to a Venus-matching trajectory. Our transfer orbit will be elliptical, with the Sun at one focus, perihelion at Mercury's distance, aphelion at Venus's distance. The semi-major axis approximately 0.555 astronomical units. Departure burn in 10 minutes. Engineers monitor propulsion systems, confirming oxidizer flow rates, fuel temperatures, engine gimbal alignment. This burn will last approximately 6 minutes, shorter than our 8-minute Mercury orbital insertion because trajectory geometry and gravity assists favor departure. 1.2 kilometers per second represents the difference between Mercury-bound and Venus-bound. Small changes in velocity produce enormous changes in destination across astronomical distances. Orbital mechanics transforms subtle engine firings into interplanetary journeys spanning months and millions of kilometers. Five minutes to burn. The spacecraft rotates to optimal orientation, engines pointing retrograde to our current Mercury orbital velocity. Outside the viewport, Mercury's gray-tan surface passes below, cratered highlands and smooth plains, the enormous Caloris Basin visible near the terminator. We explored that world, walked its surface, sampled its ice, measured its environment. Now it becomes memory rather than immediate experience. Each departure requires leaving behind the familiar to embrace the unknown. Mercury taught its lessons. Venus awaits with different mysteries. One minute. Final systems check complete. All parameters nominal. The engine ignition sequence begins. Fuel pumps spinning up. Combustion chamber temperatures rising. 30 seconds. Outside, space remains perfectly silent, perfectly still. Inside, the subtle vibration of machinery preparing for the burn. 10 seconds. 5, 4, 3, 2, 1. Ignition. The engines fire. Acceleration presses us gently into our seats, velocity increasing. The burn continues smoothly. 1.2 kilometers per second delta V, accumulating over 6 minutes of steady thrust. Mercury's orbital parameters shift from bound to escape trajectory as velocity increases. We're climbing out of Mercury's Hill sphere, that region extending 175,000 kilometers from the planet, where Mercury's gravity dominates over the Sun's. Beyond that boundary, we enter pure heliocentric trajectory, our motion governed by solar gravity alone. The spacecraft becomes a small planet orbiting the Sun. 4 minutes into burn. Velocity continues increasing, our orbit's shape transforming from circular Mercury orbit into elliptical transfer orbit. The mathematics are elegant. Hohmann transfer calculations, Kepler's laws governing orbital motion, Newton's gravitational equations predicting every meter of our path. Space is navigable through understanding. Ancient astronomers observed planetary motions from Earth, recording positions, calculating orbits. Modern engineers apply those same mathematical principles to navigate between those worlds. Knowledge transforms observation into exploration. Burn complete. Engines shut down. Silence returning. Final velocity check confirms successful trans-Venus injection. Trajectory parameters match predictions within 0.001%. We're now on course for Venus intercept in 60 Earth days. 2 months of unpowered coast begin. No mid-course corrections planned. Our trajectory already optimized. The spacecraft shifts from high-activity exploration mode to contemplative transit mode. Time now for processing what Mercury taught while preparing for what Venus will reveal. Mercury recedes behind us. The planet shrinks visibly hour by hour, its cratered surface features fading, the polar ice deposits becoming invisible, the Caloris Basin blending into general terrain. Within 12 hours, Mercury appears as a grey-tan sphere against black space, the Sun enormous beside it. Within 2 days, Mercury becomes a dot requiring magnification to observe. Soon it will be invisible to unaided viewing, but memories remain. The silence of vacuum, the harsh shadows of airless world, the surprising ice surviving in eternal darkness. This is not the first departure from Mercury. Mariner 10, after 3 Mercury flybys in 1974 and 75, remained in solar orbit, no fuel remaining for departure or return. Eventually, solar orbit degradation occurred, the spacecraft's fate unknown. Messenger mission ended April 30th, 2015, after 4 years orbiting Mercury. Fuel exhaustion led to planned impact into the northern hemisphere, the final act creating a new 16-meter crater. We depart voluntarily, our mission continuing. Mercury awaits its next visitors. The Sun still dominates our view, but appears slightly smaller each day. At Mercury's distance of 0.387 astronomical units, the Sun appears 2.8 times Earth's familiar diameter. Today, at 0.42 astronomical units, the Sun measures 2.6 times Earth's view. The apparent diameter shrinks gradually as we coast outward. By Venus arrival at 0.723 astronomical units, the Sun will appear 1.9 times Earth's familiar size. Still bright, still dominant, but no longer overwhelming. Solar intensity decreases perceptibly. At Mercury, we experienced 9,100 watts per square meter of solar radiation, creating constant thermal management challenges. Today, at slightly greater distance, 8,500 watts per square meter. By Venus arrival, 2,600 watts per square meter. a 3.5-fold reduction in solar intensity. Still 5.5 times Earth's solar constant, but the daily decrease brings noticeable relief. Thermal comfort gradually improving. Heat shield orientation adjusts. At Mercury, constant sun-pointing orientation protected the spacecraft from intense radiation, radiators working at maximum to reject excess heat. Now the shield rotates away from perpetual sun-facing. This allows greater spacecraft flexibility, rotation for Earth communication without thermal penalty. Active cooling systems throttle back, thermal load decreasing 5% daily. Engineers monitor temperature gradients throughout the hull, adjusting radiator exposure, ensuring smooth thermal transition. The spacecraft adapts as solar intensity diminishes. Your breath mirrors this gradual transition. Inhale slowly, feeling the expansion. Hold the fullness. Exhale gradually, releasing completely. Just as the spacecraft adjusts to changing solar intensity, your body adjusts to deepening relaxation. Each breath releases a little more tension. Each exhale carries you deeper into restful calm. The journey continues effortlessly. During Mercury operations, Earth was lost in solar glare. Observing homeward meant looking within 30 degrees of the sun, unsafe even with protective filters. The small separation angle made Earth invisible against the sun's overwhelming brightness. Today, at greater distance, Earth-Sun separation angle reaches 35 degrees and increasing. In 1 week, it will be 42 degrees. Soon, safe observation becomes possible. We've been away 2.7 years, 2.5 years for Earth to Mercury transit, 2 months in Mercury operations. Earth will appear as a brilliant blue-white star. At 1.2 astronomical units distance, magnification reveals a disk, though continents remain too small and distant to resolve. But the color will be unmistakable. Earth is the only blue planet in our solar system. Liquid water oceans create that unique signature. Venus appears white from its cloud cover, Mercury gray from its regolith, Mars red from iron oxide, Jupiter orange-tan from ammonia clouds. Earth alone shines blue. Home carries its identity across space. Comparative reflection begins naturally during transit. Mercury behind us now, the smallest planet at 4,880 kilometers diameter, 0.38 times Earth's size. Venus ahead, 12,104 kilometers diameter, 0.95 times Earth's size. Venus is 2.5 times Mercury's diameter, 15 times Mercury's mass. Where Mercury is a small, rocky world barely holding together, Venus is nearly Earth's twin in size and mass. Fundamentally different gravitational environments. Mercury's surface gravity measures 3.7 meters per second squared. 0.38 times Earth's gravity, similar to Mars. Walking on Mercury felt like gentle bouncing, each step lighter than Earth normal. Venus's surface gravity measures 8.87 meters per second squared, 0.90 times Earth gravity, nearly Earth normal. After months of Mercury's low gravity and spacecraft microgravity, Venus will feel almost crushing when we arrive. Bodies must adapt repeatedly to changing gravitational environments. The atmospheric contrast is most extreme. Mercury surface pressure, 10 to the negative 15th bar, effectively perfect vacuum. Only an exosphere exists, individual atoms on ballistic trajectories, sodium and potassium glowing faintly. Venus surface pressure, 92 bar, 92 times Earth's sea level pressure, equivalent to 900 meters underwater depth on Earth. The most extreme atmospheric contrast between neighboring planets in our solar system. Mercury offers vacuum, Venus crushing density. Temperature regimes differ profoundly. Mercury's surface ranges from negative 180 degrees Celsius during night to positive 430 degrees during day. 610 degrees variation, the largest temperature range in the solar system. Venus maintains uniform 465 degrees Celsius day and night, equator and poles. Massive atmospheric greenhouse effect creates perfect heat redistribution. Mercury challenges with variation, Venus with relentless constancy. Different extremes requiring different survival strategies. Rotation periods reveal another contrast. Mercury rotates once every 58.646 Earth days prograde, locked in 3:2 resonance with its orbital period. This creates a solar day lasting 176 Earth days. Venus rotates once every 243 Earth days retrograde. The only planet with retrograde rotation besides Uranus's extreme tilt. This creates a solar day of 117 Earth days, the slowest rotation in the solar system. Mercury's rotation explained by tidal locking. Venus's retrograde rotation remains mysterious. Day 5 of transit. Current position, 0.45 astronomical units from the Sun, 100 million kilometers outward from Mercury, 8 million kilometers remaining to Venus. Solar intensity 7,000 watts per square meter now, continuing its gradual decrease. The Sun appears 2.4 times Earth's familiar diameter. Heat continues diminishing, thermal systems continuing their adjustment. Spacecraft interior temperature decreasing from barely tolerable to genuinely comfortable. Amazing how adaptable human perception becomes. What felt normal at Mercury now feels warm. Earth becomes visible today. At 40 degrees separation from the Sun, safe observation is finally possible. Through the viewport, magnification reveals Earth as a blue-white star of stunning brilliance. Distance is 1.2 astronomical units, 180 million kilometers. At this range, the disk is visible, but continents are not. Only that unmistakable blue color, oceans reflecting sunlight, atmospheric scattering creating the unique signature no other world shares. After 2.7 years away, Earth reappears. Home persists. Crew psychology shifts during unpowered coast. Chris Hadfield described it from ISS experience. The space station is constant activity, experiments and maintenance and emergencies, Earth passing below. Interplanetary transit is different. Nothing changes for weeks. Same stars, same spacecraft, slow planetary motion barely perceptible. Psychology shifts from busy professional to contemplative observer. You process where you've been, prepare for where you're going. Transit provides the gift of time. Scott Kelly's year-long ISS mission taught adaptation. First month in space, everything feels novel. Third month, routine establishes itself. Sixth month, time perception changes, weeks feeling like days. After 340 consecutive days in space, Kelly learned humans adapt to anything given sufficient time. 2 months Mercury to Venus transit feels short after the 2.5-year Earth to Mercury journey. The body adjusts, the mind accommodates, resilience emerges. Peggy Whitson accumulated 665 days in space across multiple missions. She emphasized that transitions matter profoundly. Between spacewalks, between missions, between activities, the body and mind need reset time. Mercury to Venus transit provides exactly that. Leave behind one extreme environment, vacuum, thermal extremes, low gravity. Prepare mentally for the opposite extreme, crushing pressure, acid clouds, Earth-like gravity. Transit is a gift allowing adaptation. Mercury possessed a weak magnetic field. Surface strength 300 nanotesla, about 1% of Earth's magnetic field strength. This indicates an active liquid core, despite Mercury's small size, a planetary mystery. Venus has no intrinsic magnetic field at all. Either the core solidified, or rotation is too slow for dynamo action. Solar wind interacts directly with Venus's atmosphere, creating an induced magnetosphere rather than a protective magnetic bubble. Same inner solar system, opposite magnetic environments. Surface ages reveal geological histories. Mercury's surface is 3.5 to 4 billion years old. Ancient, cratered terrain, preserving minimal resurfacing since the late heavy bombardment. The impact record remains pristine, readable, a geological history book. Venus's surface is 300 to 500 million years old. Global volcanic resurfacing erased all ancient features. The surface is geologically young, despite Venus forming 4.5 billion years ago alongside Mercury and Earth. Ongoing volcanic activity is suspected based on atmospheric variations. Cratering patterns illustrate this age difference. Mercury shows heavy cratering, 80% coverage with craters larger than 10 kilometers diameter. Impact record pristine and complete. Venus shows only 1,000 impact craters total. Volcanic resurfacing erased older craters. The thick atmosphere burns up smaller impactors. Only craters larger than 3 kilometers diameter survive to the surface. Atmospheric protection, combined with geological activity, creates young appearance. No two worlds are alike. Mercury and Venus are neighbors in solar system architecture, both sharing the inner realm. Both rocky terrestrial planets formed from the same primordial material, yet utterly different in every measurable way. Comparative planetology reveals diversity. Earth is not the template. Earth is one outcome among infinite possibilities. Understanding Mercury and Venus teaches us what Earth could have been. Day 12 of transit. Current position, 0.5 astronomical units from the Sun, halfway through the transfer orbit's geometry. Solar intensity 6,000 watts per square meter, still decreasing daily. Mercury is now invisible to unaided observation, requiring telescopic magnification. Venus remains a white dot ahead, not yet resolvable as a disk. We exist between worlds in heliocentric void. This is the nature of interplanetary space, vast emptiness between destinations. Microgravity returns after Mercury surface operations. For 30 days we walked in 0.38 g, bodies adapting to low but present gravity. Now weightlessness surrounds us again. Initial awkwardness emerges as muscle memory expects gravity that isn't there. Objects float when released. Orientation becomes arbitrary. But within days, 0G proficiency returns, the body remembering its adaptation from the long Earth to Mercury journey. Humans are remarkably adaptable organisms. Exercise regime resumes. 2 hours daily maintaining bone density, muscle mass, cardiovascular fitness. Resistance equipment. Treadmill with restraint harness, cycle ergometer. Venus gravity at 0.90 g will feel nearly crushing after months of weightlessness. The body must be prepared. Bones must retain calcium, muscles must maintain strength, heart must sustain Earth normal workload capacity. Without exercise, arrival at Venus would be medically dangerous. Spacecraft velocity changes through the transfer. At Mercury departure, we traveled 47.4 kilometers per second orbital speed. Now, at solar system's gravitational midpoint, velocity gradually decreases. By Venus arrival, velocity will be 35 kilometers per second. Kepler's second law. Objects move slower when farther from the Sun. This creates the perception of drifting rather than traveling. The spacecraft coasts effortlessly along its predetermined elliptical path. Your breathing mirrors this gradual deceleration. Each breath slightly slower than the last. Inhale deeply. Notice the gentle expansion. Hold that peaceful fullness. Exhale slowly, releasing completely. Your body drifts into deeper relaxation. Each breath carries you further into restful calm. Day 20 of transit. 1/3 complete. 40 days remaining. Solar intensity 5,000 watts per square meter. Sun appears 2 times Earth's familiar diameter. Thermal systems operating comfortably now. The constant solar pressure that dominated Mercury operations diminishes to manageable levels. Heat shield fully retracted, no longer needed. This brings profound relief after 2.7 years of sun-intensive operations. David Grinspoon advocates for Venus atmospheric missions. Everyone loves Mars because of water evidence and potential life and human colony concepts. Venus gets overlooked because the surface is hellish. But Venus's atmosphere is accessible. At 50 kilometers altitude, the pressure is 1 bar, Earth sea level equivalent. Temperature is 75 degrees Celsius. At 55 kilometers, 0.5 bar pressure, 27 degrees Celsius. Shirt-sleeve environment in terms of temperature and pressure. Venus deserves reconsideration. David Blewett worked on messenger imaging. He emphasizes that Mercury taught us small planets retain surprises. Hollows forming today, magnetic field persisting, polar ice surviving against predictions. Venus will teach different lessons. How atmospheres evolve, how greenhouse effects develop, how planets lose water over geological time. Each world becomes a laboratory for planetary processes. Comparison reveals principles. Ellen Stofan, former NASA chief scientist, articulates it clearly. Study Mercury alone, you learn about Mercury. Study Mercury and Venus together, you learn about terrestrial planet evolution. Mercury lost its atmosphere, too small and too hot to retain volatiles. Venus retained its atmosphere too well, runaway greenhouse, transforming temperate world into hellscape. Earth balanced between these extremes. Comparison teaches universal principles governing all rocky worlds. Day 30 of transit. Halfway complete. 30 days remaining to Venus. Current position, 0.555 astronomical units from the Sun. The transfer orbit's semi-major axis. Mercury and Venus are equidistant now. One receding behind, one approaching ahead. Both currently invisible. Mercury lost to distance, Venus not yet resolvable. We inhabit the space between, the void connecting worlds. Solar intensity 4,000 watts per square meter, decreasing toward Venus's 2,600. Thermal comfort continues improving daily. Spacecraft interior temperature stabilizes at comfortable levels. What once felt unbearably hot at Mercury now registers as pleasantly warm. human perception adapts remarkably to changing baselines. Communication evolution continues. Mercury communication suffered from solar interference and 8 to 12-minute light delay. At Venus distance, Earth-Venus light delay ranges 2 to 14 minutes, depending on planetary positions. Communication windows are more favorable here. Less solar radio interference at 0.723 AU than at 0.387 AU. Contact with Earth improves as we depart the innermost region. Unpowered coast provides contemplative time. After departure burn, spacecraft coasts ballistically for 2 months. No mid-course corrections planned. Minimal systems operations required. Crew shifts from high-activity Mercury exploration to contemplative transit mode. Time for reading, for viewing Earth and stars, for processing experiences, for preparing mentally for Venus's different challenges. The journey provides space for thought. Venus becomes visible ahead now. A white dot growing slowly, featureless even under magnification. Cloud cover obscures everything. Brilliant reflectivity makes Venus third brightest object in Earth's sky after Sun and Moon. 76% albedo, highest in the solar system. From here, Venus appears simply white, uniform, revealing nothing of the crushing atmosphere or volcanic surface beneath those clouds. Day 40 of transit. 2/3 complete. 20 days remaining. Solar intensity 3,500 watts per square meter, approaching Venus's orbital conditions. Sun appears 1.95 times Earth's familiar size. Still bright, still dominant, but no longer overwhelming. This represents profound relief after years of solar intensity management. Robert Zubrin advocates for Venus colonization concepts. Mars gets attention because the surface is accessible. Land, build habitats, extract resources. Venus' surface appears impossible with current technology. 465 degrees Celsius melts lead. But Venus's atmosphere is resource-rich. Carbon dioxide for manufacturing, sulfuric acid for industrial chemistry, solar energy abundant. Floating cities above the clouds bypass surface challenges entirely. Think three-dimensionally. James Cutts studies Venus atmospheric missions at JPL. Mercury teaches extreme environmental engineering, thermal protection, radiation hardening, vacuum operations. Venus teaches different extreme engineering, pressure vessels, corrosion resistance, buoyancy control. Transitioning between missions requires mental shift from vacuum problems to pressure problems. Each world demands specialized solutions. No universal spacecraft works everywhere. Engineering adapts to destination. Day 50 of transit. Final 10 days approaching. Venus fills more of the view now. White clouds, swirling patterns visible in ultraviolet imaging. Atmospheric superrotation creates 4-day cloud circulation, despite 243-day planetary rotation. Hurricane-force winds at altitude, calm at surface. Inverse of Earth, where surface has weather and stratosphere remains calm. The Venusian cloud deck spans 48 to 70 kilometers altitude. Sulfuric acid composition, permanent global coverage. Reflects 76% of incoming sunlight, creating brilliant white appearance. Obscures the surface completely in visible light, never clearing even briefly. Radar penetrates clouds. That's how Magellan mapped 98% of Venus's surface. Atmospheric composition is hostile. 96.5% carbon dioxide, 3.5% nitrogen. Trace amounts of sulfur dioxide and water vapor less than 0.01%. Dense, acid-laden, chemically aggressive to most materials. Requires specialized protection beyond thermal challenges. Engineering for Venus demands corrosion resistance equal to thermal management. Despite thick clouds, surface receives about 5% of incident sunlight, equivalent to heavily overcast day on Earth. Sufficient for solar-powered operations. Orange-red tint due to atmospheric filtering. Photographs from Venera landers showed clear ground visibility, not perpetual darkness. Dim twilight illumination. Historical missions demonstrate Venus accessibility. Mariner 2, in December 1962, achieved first successful planetary flyby, confirming high surface temperature. Venera 7, in 1970, achieved first successful planetary landing, surviving 23 minutes. Pioneer Venus Orbiter operated 14 years, from 1978 to 92. Magellan radar mapped the surface 1990 to 94. Akatsuki continues atmospheric study from 2015 to present. Soviet Venera program achieved remarkable success. 28 Venus missions over 23 years, from 1961 to 84. First successful planetary landings. First surface photographs from Venera 9 in 1975. First surface analysis from Venera 13 in 1982. demonstrated capability to survive 465 degrees and 92 bar for up to 127 minutes. Venus surface operations are brief but possible. Day 57 of transit. 3 days remain to Venus orbit insertion. Final trajectory calculations confirm intercept parameters. Insertion burn will last 6 minutes, less delta V required than Mercury orbit insertion due to trajectory geometry. Venus's larger mass creates stronger gravity, 2.5 times Mercury's strength. Orbit will be easier to maintain once captured. Crew prepares for Venus operations. Unlike Mercury surface landing, Venus mission will be atmospheric. Aerostat balloon habitat deploys at 50 to 55 kilometers altitude. Temperature 27 degrees Celsius. Pressure 0.5 bar. Shirt sleeve environment regarding pressure and temperature. But sulfuric acid clouds require containment. Engineering challenge is corrosion resistance. What did Mercury teach? Survival at extremes. Thermal, radiative, gravitational. Patience. 30 days surface operations after 2.5 years travel justified the journey. Resources enable presence. Ice in shadows transforms destinations into sustainable outposts. Magnetic mystery. Small planets retaining liquid cores defies simple models. Ancient surfaces preserve 4 billion years of readable history. Venus will teach different lessons. Atmospheric evolution, how greenhouse effects develop and persist. Volcanic activity, geologically young surface indicates ongoing processes. Rotation mysteries, why retrograde? Why so slow? Habitability boundaries, surface impossible, but atmosphere accessible. Each world expands understanding. Day 59. Tomorrow, Venus orbit insertion. 2 months between worlds complete. Mercury taught temperature extremes, vacuum survival, ancient preservation. Venus will teach pressure extremes, atmospheric complexity, volcanic youth. Earth exists between these extremes. Moderate temperature, moderate pressure, moderate geological activity. Earth is Goldilocks planet not because of location, but because atmospheric evolution balanced. Venus proves habitable. Distance alone is insufficient. Atmospheric composition determines habitability. Venus' runaway greenhouse is cautionary tale. Positive feedback loops transformed temperate world into hellscape. Mercury's atmospheric loss warns small planets cannot retain volatiles. Earth balanced between extremes. Comparative planetology teaches Earth's specialness. Three terrestrial planets within 150 million kilometers. Three completely different outcomes from similar starting materials. Understanding why teaches principles governing all rocky worlds everywhere. We left Mercury wiser. We approach Venus curious. Tomorrow insertion burn. Venus atmosphere awaits. Clouds concealing secrets. Superrotation defying explanation. Surface volcanic and young. We carry Mercury's lessons into Venus's mysteries. The journey continues. The exploration expands. The solar system reveals itself, world by world. Engines test fired successfully. Trajectory nominal. Venus 100,000 kilometers ahead. Systems prepared. Crew rested. Mission continues seamlessly. One extreme to another. Tonight, peaceful anticipation. Tomorrow, Venus orbit insertion. Atmospheric entry approaching. Aerostat deployment planned. Floating above hell at comfortable altitude. Journey inward to Mercury, outward to Venus. Eventually homeward to Earth. All mathematical. All planned. All achievable. Space is navigable. Planets are reachable. Humans adapt. Explore. Understand. Venus tomorrow. Tonight rest. Peaceful drifting. Gentle approach. Microgravity surrounds. Silence envelops. Stars unchanging. Journey continuing. Sleep comes gently, knowing tomorrow brings new world, new challenges, new discoveries. Transit complete. Exploration continuing. Venus awaits. Rest now. Two months between worlds. Processing complete. Preparation complete. Tomorrow begins. Floating peacefully, drifting gently. Venus approaching. Sleep deeply. Breath slowing, body relaxing, mind quieting, rest earned. Journey inward complete. Journey outward continuing. Eventually homeward. Sleep now. Mercury memories, Venus mysteries, Earth awaiting, peaceful rest. Stars surround you. Silence holds you. Space embraces you. Sleep comes. Weightless drifting, effortless floating, perfect peace, deep rest. Venus tomorrow. Tonight, tranquility. Insertion prepared. Body rested. Gentle breathing, slow heartbeat, complete relaxation, total peace. Journey continues. Sleep deepens. Venus approaches. Rest completely. Between worlds, between breaths, between thoughts, pure calm. Exploration awaits. Tonight, rest. Tomorrow, Venus. Sleep now. Infinite stillness, perfect quiet, peaceful completion, deep sleep. Drifting, floating, resting, sleeping. Transit complete. Rest deserved. Venus tomorrow. Sleep tonight. Peaceful journey, gentle arrival. Tomorrow begins, tonight ends. Stars watching, silence protecting, sleep embracing, rest complete. Venus awaits. Sleep now. Perfect peace. Complete rest. Orbital insertion tomorrow morning. Tonight, the cosmos holds you gently. Every star a distant sun. Sleep deeply now. Two planets explored, one journey connecting them. Your breath, the only motion. Rest completely. Venus glowing ahead. Stars surrounding. Peace descending. Mercury behind, Venus ahead, sleep between. Weightless floating, endless drifting, perfect stillness. Tomorrow, new world. Tonight, pure rest. Sleep deeply. Journey continuing. Body relaxing. Mind releasing. Between worlds, between thoughts, pure peace. Breath slowing, heartbeat calming, sleep coming. Stars watching. Silence holding. Rest arriving. Venus tomorrow. Sleep tonight. Complete peace. Gentle drifting, perfect calm, deep rest. Journey peaceful. Arrival near. Sleep now. Cosmos embraces. Sleep descends. Rest complete. Floating gently, sleeping deeply, peace total. transit ending, rest beginning. Sleep now. Venus near. Sleep here. Perfect peace. Stillness complete. Rest total. Sleep deep. Journey done. Sleep begun. Peace eternal. Rest now. Sleep deep. Peace complete.